just practicing here how to put functions into completing the square format. You can obviously ask questions as to why it looks like this. You can look up GeoGebra, etc. and see why this happens, but just in this video I'm just doing how to put it into completing the square format. So we'll just practice a few. So if you have a function f of x is equal to x squared plus 8x plus 7, we're looking at this number here, and when the coefficient is a 1, there's no, there's nothing that we have to consider. So I'm just going to look at this coefficient here. I'm going to half it and square it. So I get x squared plus 8x. The coefficient I'm halving and squaring and adding 16, but they're not the same. So, I mean, you have options here where you could just add 16, subtract 16 and add 7, or you can just balance it out now. So it is supposed to be a plus 7. I have it down here at the minute as a plus 16. So I need to minus 9 in order for them to be the same. So when I have it like this, I now look at this part here and I'm looking at, well, if I factorize that, I'd end up with x plus 4 to be squared. Obviously take it to the side and factorize it if you need to, minus 9, which means that it's now in completed square format, and my turning point for this one is minus 4 minus 9. Next one. So if we had another function and it looked like this. Now, as I said, I'm only just doing the method here, just practicing the method, not going into any detail as to why this happens or how it happens. So I take the coefficient, I halve it and square it. So I end up with x squared minus 4x. When I halve this and square it, I end up with plus 4. And if I compare now, it was a plus 7, so I need to add on another 3. Or as I said, you could plus 4 minus 4 plus 3, just to work that out. This is x minus 2 squared, and then plus 3. Now it's in completing the square format, and I can pick out my turning point is 2, 3. You can do all this using calculus as well, but if they're just specifically asking me to do this format, then that's what I have to do. So now we're going to look at one with a coefficient at the start. I'm going to take the coefficient out in common. I'll have to take this into account now at the end, that I've taken a 3 out in common. So again, I'm looking in here and I'm looking at taking the coefficient, halving it and squaring it. When I half this and square it, I end up with a plus 4. Now, I have a plus 4. It wasn't a plus 4 though. It was 3 and 3 1/3, which means plus 4, and I need to do minus 2/3. So I might just explain that again. That I got this, that's fine. That's fine. And in order to get this number here, I took the coefficient of the x, I halved it and squared it and got the plus 4. But when you look at what was there, it was a plus 10/3. So it was plus 3 1/3. I'm now putting down a plus 4. So plus 4 minus 2/3 gives me the 3 1/3. So I haven't changed anything now. Again, the other way that you could say this is, plus 4 minus 4 plus 10/3, and just work it out in the end. Right, so I keep my 3 outside here. Factorise this, and I have x minus 2 to be squared minus 2 over 3. Nearly there. I'm going to just kind of, I suppose, 3 by this gives me 3 minus 2 to be squared, and 3 by this gives me a minus 2. So now it's in completing square format. I can pick out lowest point is 2 minus 2. So one more maybe of those. 2x squared is 4x minus 7. Again, I'm going to take the 2 out here. And now I'll get this into completing the square format. So x squared plus 2x. I'm going to half this and square it. And then I have a plus 1 already now, but this is minus 3.5. So plus 1 minus, I'm going to have to go to 4.5. So that's that, and that's that. So I haven't changed anything. But now what I can do is I can see here that I can write this as x plus 1 squared minus 4. And now, as I did last time, I'm going to multiply by the 2. So that's 2 times x plus 1 to be squared minus 8. Now I can see turning point minus 1 minus 8. Now you could get a question with function being 14 minus 12x minus x squared. I'm going to move this round to have the minus x squared first, minus 12x plus 14. And I do have a coefficient in front of the x squared here. It's a minus 1. If it was just a 1, I'd leave it, but I'm going to take the minus 1 out in common. So I have x squared plus 12x minus 14. And I continue doing what I did before. Get this half it squared. It was a minus 14. Now I have a plus 36, so I'm going to subtract 50 to get back to the minus 14. This part here, I can now write as x plus 6 squared minus the 50. I'm going to multiply by the minus 1. So now I can tell turning point minus 6, 50. Or the lowest point on the graph. Well, actually, I suppose in this case, because, sorry, it's the turning point I'm getting. It's the highest point in the graph because we have an N-shaped graph here. Last one that I'll do is just, what if they asked you to do with a variable in it? So let's say they gave me the function f of x is equal to minus 2x squared minus 24x plus m. I'm going to take the minus 2 out in common. It's a minus. Okay, so if I multiply that back out, I'd have the top line. So I took the minus 2 out in common. I have x squared, again, halving and squaring to get 36. Now, I haven't a clue what this is. So the easiest thing to do here is just to, do as I was saying earlier on, where you might just add 36. Well, subtract 36. And I haven't changed a thing. because 36 minus 36 is 0. So I have my x squared, my 12x plus 36 minus 36, and my minus m over 2. This part here can now be x plus 6 to be squared. And then we have minus 36 minus m over 2. I'm going to multiply in by the minus 2. And we get minus 70, no, plus 72 plus m. So what can we tell now? Turning point, or yeah, the highest point in this graph, because again it's minus x squared, is minus 6 and then 72 plus m.